Okay, thank you. Thank you. I don't know if this is playing in PowerPoint or on the app or whatever, so I have a video, but it may or may not. I'm not sure. It's embedded, so hopefully it will. I'm the Change Manager with Southern Regional College, and I'm involved with the process from design and construction right through to FM. So a lot of what we spend our time now doing is connecting that gap between the design and construction side and the actual facilities management side. So what we wanted to do as a client was explore the generative design software in a live environment and compare it to the creative process that a commercial architect would do. And it was during stage 2 of our innovation centre, and the first challenge we had was how do you write an innovation clause that brings in generative design when you have a supply chain who may know an awful lot about Dynamo or Grasshopper or whatever, and another supply chain tendering who may know nothing. So to overcome that problem, what we did was we first of all identified the output, which was an industry report, which I think we could make available. And the second thing was we defined the roles, which was ourselves as the client, so we had to participate. The design team, and we asked for a designer plus a quantity surveyor, and we specified it as 4 workshops so that anybody present would know, well, I have to attend 4 workshops with these people. And that allowed us to at least write an innovation clause without sort of scaring the horses. At a stage 2, we were looking at a design partner. And we ended up with McCallum Design, and we were hoping that we would get someone who would be a partner rather than just someone delivering a clause in a contract to the minimum standards. And we did get that with McCallum Design. It's been excellent. The site was in Newry. It's a vacant site beside one of our existing campus buildings in Red, and we put out a tender. Very quickly, I'm not sure what the audience is here, whether people know about generative design or how familiar they are. So if we had our, say, 20,000 square foot building, and we were varying the depth by 18, 20, 22, and we were varying the height by the number of floors, and that would give us in this instance 9 potential solutions. So that was the principle of it. You put that into the software, as I'm sure many of you know, and on the left hand side you have the visual coding, programming, and then on the right you can see the actual geometry. Just very quickly I'll go through this just again in case I don't know who the audience is, but if you had those 9 designs and you pick a generation of one, and let's say you're comparing it against the lowest cost for your fabric, once you've found the lowest cost, you can use it to generate the next generation, and then you can use it to generate the lowest cost of the second generation. You could use to generate the cost for the designs for the third, and then eventually you find the most cost-effective design. Now, obviously, 9 designs through what the run online, which would be that difficult. But in our case, we had 10,000, it was 300 and something designs that we were potentially looking at, because we were varying depth, location, window glazing, etc. The next thing, where does it fit in an architect's design process? We see generative design in the planning phase. In terms of space planning, we've seen it at the form, which is where we applied it, and then in the fenestration or maybe even in the fabrication of cladding. And for the architects in the room, that last slide, if it's form follows function, we're now having a bit of a discussion about that, whether it should be the other way around with generative design. Our 4 steps were, we initially, whenever the architect was appointed, they didn't know their final concept, so we had to do a proof of concept of the actual generative design model to make sure it would work for us. So during stage 1, we developed this, and the red lines indicate the variables, because you are very much taking a mathematical mindset to the design, a creative process. So we have to map that out. And in this case, we thought we were going to have an atrium, possibly a return in the back of the building, and maybe a projection at the front of the building. So we were kind of trying to cover all possibilities. Then, once the architect had determined the actual concept, it was much simpler than that. It was a detached building, so we then built a second generative design model with McCallum Design's concept. And then the third step was we got the information out to do an analysis of it. And at that stage, when we were doing this, the Revit Dynamo wasn't really exporting out the Excel. I did do it later on in the process in the release of the later version. So the actual analysis, when we were able to get the data out of Dynamo, we were able to do much better analysis. And then finally we produced the report, which is to say, happy to share. It's written for the layperson report, and then it also has in parallel writing, which gives a wee bit of insight into the likes of the calculations and the algorithms and the thinking behind that for anybody that's more familiar with the technology. And the reason why it's written for the layperson is a lot of them we find is written for specialists, and it has now become a wee bit of a dark science. And what we believe is that you need to convince the funders, and you need to convince the project managers, and you need to convince the caretakers, and you need to convince the estates managers. And therefore, we're now starting to write things at two levels, at that layperson, we call it what your ground would understand level, and then basically for maybe the information managers or the more highly technical. So the report is written for, it's nearly to try and make a conversation happen with funders in Northern Ireland, and you'll see why. We decided to pick 3 goals because the design is what's known mathematically as a complex problem. There's not one solution, but there's a number. It depends on which goal you decide you want to go with. So, for example, if you say I want to build the cheapest building, well, it might have the highest running costs. So if you have those 2 goals, they nearly contradict one another. We chose cost, and we chose to use the new rules of measurement. We picked those elements out of the stage, which we knew were going to be in the stage 2 report. So we were able to sort of use that cost analysis from the stage 2 to calibrate the actual calculations. We used the PHPP calculation from Passive House, and we challenged ourselves with something which was probably maybe the architect and me to sort of measure something that wasn't measurable, visual impact. And I think, you know, if you look at things at the moment, we can measure time, we can measure cost, but regarding quality, it's harder to measure quality in terms of architecture. So that was something I wanted to know, could the new technology, because it can measure views, it can measure room adjacencies, it can measure daylighting factors. So I think with technology, maybe there's opportunities there to kind of measure the architecture. And this is what the software, I don't know if this video will play or not, but again, to try and explain, you see the blocks, but if you look at the top blocks, the coloured ones, the yellow, the grey, the yellow, they're really just forming the context. And then in the lower one, you'll see that we're actually then putting in the inputs and then some of the calculations. And then the bottom right is actually just creating the geometry. So a lot of this sort of, if the coding is packaged up and it works really well, I think somebody earlier on saying you could actually nearly reduce it down to one code. In fact, I'm kind of coming to the conclusion that we'll this play or not. Oh, it's going to play right. So on the top left, just again for anyone that's not overly familiar with it, you can see that we're just creating the site. Creating the road and we're creating the adjacent buildings. This is us creating the existing campus, these, and then to the right of that, then we are creating, sorry, that's the existing campus in the yellow. And then down below here, what we have are the variables that are coming in to the actual calculation, the glazing variables, so that's the percentage glazing. And then what we have, each one of these is the visual impact calcs, the energy calcs, the cost calculation calcs. And then on the right, once we've done that sort of analysis, if you like, then we move over just to create the geometry. That's Dynamo. That's Dynamo. So generally for the general design at that stage, we've been looking at, there was Grasshopper and Dynamo. We had Dynamo available to us. I think I would have preferred to have had Grasshopper, particularly for the energy, because it had things like Ladybug, plugins, etc., which were very useful. So again, you can see here, again, for people who are not familiar, let's say we were varying, say, the number of floors NF, we're varying the location of the building. You can see the building in the background starting to change its shape so that you can see what that might look like. And again, I'll take it for one more section, then we'll move on. But it allows hopefully the people that maybe aren't familiar with the software to see that you can start to vary things, and that building would have varied all around the site. So it's 10,000 something various solutions there from very few, well, not an awful lot of variables. It does sort of multiply up quite quickly. So you can see that's a 4-story version of the building. So what we wanted to do then whenever you get that out, you can analyse it through different methods. At that stage, Dynamo offers these splatter charts, and what you're looking for are patterns. and that's really what AI is looking for. It's just looking for patterns. So you're looking for the patterns in the data to see if there's something happening that you can sort of avail of. And it offers you the splatter charts. It offers these, I think they're called parallel coordinates, I call them spider diagrams. And each one of those blue lines is like a solution, one potential solution. And then on the left-hand side are the studies. So you might, for example, if we have 10,000, you mightn't run all 10,000 because the machine might be very slow. So you might run, say, 500 based on certain limited variables. And then you can run another study and another study. So in our case, we ran 3 particular studies for the cost, which I'm going to show you. And again, I know in 5 or 10 minutes it's difficult to kind of explain all this, but on the 2 dark lines on the left are your goals. So you can see the cost, which was the cost for the fabric only. It wasn't the cost for the internal walls, it was purely the cost of the fabric and the walls and the floor and the roof. Then you've got the heating cost, and again we didn't take into account cooling because we wanted to kind of test the thing about it. And then we had the visual impact. So in this particular one, when we ran, you could see that a lot of the solutions that were low cost were actually coming up as being a high number of floors. So that's what that was suggesting, was that if you were to build a 4-story building, it's going to be a lot cheaper than if you just built a 2-story building. So that's cost study 1. Then what we did was we decided to vary the dimensions of the building in terms of its depth, and ran again. And again, it seemed to be that the lower cost was coming out of the higher number of floors, but the depth of the building wasn't making a significant difference to that. However, we had to then calibrate it, and what we calibrated it with the actual cost at stage 2. So the designers put through their final design, put through their costs, and then we used it to calibrate the calculations in the model. And a couple of things we found out were that the general design was overly simplified. So you can see the actual design down below, and then our model was actually quite a few bits. So we had to put in a factor for complexity. We found that the design had voids, whereas our original generative design model didn't have voids. So we needed to add those in, which we did. And then there were a few mathematical errors. I don't know who made those, but we did get them fixed. And then we noticed that we were measuring gross floor area. We really needed to measure net internal floor area, because if you have an extra floor, you have an extra stair area, etc. So those were kind of some of our lessons learned. And then when we did all that, the number of floors had less impact on the cost. And we're dealing here with only 3 variables, and as I say, a very complex design process, because you could find, well, we could build it 4 stories, but really that doesn't work. It gives you maybe more car parking, but then the connectivity between rooms or rooms adjacency might not be. So you have to take all of these into account. Plus, we were obviously looking at funding for the next stage, and what we didn't want to do was to say we might be building an optimized solution. So this is again, we took a wee bit of the the data, we did a wee bit of analysis, and what we looked at was just straightforward data, highest, lowest, mean, average, etc. What it was kind of saying was that if we built a high number of floors for the same building, it might come in at about £250,000 cheaper than that would be on a £14 million project. However, it has to come with a big caveat. We're only really testing it. I'm not sure that that's a fair comment to make, let's say the number of floors, etc. Lessons learned were the generative design. It does open doors to optimization. It's a nice entry level. Although there's better entry levels now. Some of the software that we've shown earlier on in the morning. The software is complex. It's not a mainstream. I still don't think for your average designer. The export data is now good if you can get it out, and I think there's other places you can analyse it much better. You need, I think, a space adjacency matrix, and I'm going to back that in a minute. I think it's a very good thing for cost consultants and embodied carbon, and for I think we need to look more at measuring that net internal floor area. I can't go into the visual thing here, it is in the report, but we did think that the visual had its merits, and we were able to generate the highest scoring visual impact against the existing building and generate the 2 models and show the visual. And you would have said, yes, if I was driving past on the street, I would have seen that building more than if I had built it where we did. And then the energy, we really found it worked okay, because what you're trying to do is take a lean calculation, but the shading factor within the passive house was the big one for us, and that as I say, we're now exploring that a wee bit in other software that I think are more suitable. And then we're moving that now towards a conversation around digital twins and calibration of the likes of IAS models and stuff. So you could use it for optimizing costs and plugins. So what's the kind of the message that we would be sending out? If you're going to look at a kind of a creative process, or you're going to look at a data-driven process, you know, that's the kind of conversation we're having now. I work with the RSUM, we have a design innovation committee, and we're starting to initiate those conversations with people. I personally believe that a creative person will be creative with a pencil or an algorithm, so it doesn't really matter, you just give them things to be creative. But if you're going to give a data-driven process, the client needs to be given the data in a flexible way. So what we're looking at the moment is it has to be not what happens up north, we think a lot of the time is you get a schedule of accommodation coming from the business case. What I really think is you need a room adjacency matrix or tolerances if you really want to maximise the optimization process. And the funding sector is not really there to do that. It's not like somebody says, well, there's 8 million, and if you get it built for 7, you can keep the 1 million. They take the 1 million back and off you. So there's no incentive. Again, we look at it in the forum, but if you can give the designers the data and you give it to them in the right way, I think the tools are out there, whether it's Dynamo, Grasshopper, or some of the other ones that we've looked at, or even just, I kind of come to the conclusion, if you just go in and program the thing in Python, you maybe don't even need to see the design. You could optimize it and use other methods to optimize it and then create the geometry after you've done optimization. So you're really thinking more like a data canvas. And then finally create the geometry, and that's where the automation comes in, so it's just created automatically. The report's available, as I said, I think it's through Alan, and I think that's it. It was a very useful exercise for us. It was to test it out, and I think there are definitely benefits in it for a client.
Thanks for making it all.
Yeah. Thank you.